Good morning students. Today 4th April, first lecture, chapter 1 continue. Example 1.11. It is one example based on Gauss. See what is given. You are given components of electric field. Ex is equal to alpha x raised to 1 by 2. Ey is equal to Ez is equal to 0. It means electric field is only in x direction. Electric field is only in x direction, and it is not uniform. It is varying with distance because Ex is equal to alpha x raised to 1 by 2. As x increases, electric field also increases. Alpha is equal to 800 Newton per Coulomb, meter raised to 1 by 2. A is equal to 0.1 meter. Your question is, what is flux passing from this tube? Charge within this tube. You have to find two questions. What is flux and what is charge within this tube? You are given figure. See, it is one cube having side A. X, Y, Z coordinate system. As electric field is in only x direction. Electric field is only in x direction. Okay? Okay. Name this cube A, B, C, D, P, Q, R and S. This cube has 6 faces. Total 6 faces. So what is total flux passing from this cube? Flux passing from each and every face, and we will add them. First of all, we have to find flux passing from each and every face, and then we will add them. See, as electric field is in x direction, electric field is in x direction. See, this face ABCD, A, B, C and D, ABCD, this face, okay, at bottom. We know that area vector is always perpendicular outside, so its area vector will be in downward direction. Its area vector will be in downward direction. Its area vector will be in downward direction. So what is angle between electric field and area vector? 90 degree. Clear? Similarly, for face PQRS, area vector is perpendicular outside. So again, angle between electric field and area vector is 90 degree. Okay. So for face ABCD and for face PQRS. Also for faces APQB, means this face. Okay, its area vector is perpendicular outside. Electric field is in x direction. Angle between them is 90. And for this face, okay, for this rear face, that is DSRC, area vector is perpendicular outside, perpendicular to this board going inside. So for these four faces, A, B, C, D, P, Q, R, S, A, P, Q, B and DSRC, electric field and area vector, they are normal to each other, means angle between them is 90. So flux passing from them is 0. Now we have only two faces left. Face A, P, S, D and B, Q, R, C. Now we will find flux passing from these two faces. See, for face ABSD, it is ABSD. First of all, we will find magnitude of electric field. See, what is equation of electric field? Ex is equal to alpha x raised to 1 by 2. E is equal to alpha x raised to 1 by 2. See, from figure it is clear this face is at distance A from origin. This face is at distance A from origin. So you have to put x is equal to A. You have to put x is equal to A. So E is equal to alpha A raised to 1 by 2. Clear? Okay. Now, see, this face is like this. So its area vector is always perpendicular outside. So its area vector is in this direction, ds. Okay, so from figure it is clear. Electric field and area vector, they are in opposite direction. So angle between them is 180 degree. Angle between them is 180 degree. So flux passing from this phase APSD, phi 1 is equal to E ds cos 180. E alpha a raised to 1 by 2. ds means area. It is cube of side A. So what is its area? A square. Cos 180 minus 1 minus sine alpha as it is. A raised to 1 by 2 into a square means A raised to 5 by 2. 1 by 2 plus 2 it is 5 by 2. Clear? So it is flux passing from this phase. Now for this phase, see, for phase QRCB. What is distance of this phase from origin? For this phase, this distance is A. Side of cube is A. So obviously distance of this phase from origin is A plus A means 2A. See, for phase BQRC, magnitude of electric field E is equal to alpha x raised to 1 by 2. Alpha, what is value of x? Yes, 2A. Okay, 2 raised to 1 by 2 means root 2. Alpha A raised to 1 by 2. A raised to 1 by 2. Now see in figure, for this phase, area vector perpendicular outside means in this direction, ds. So E and ds, they are in same direction. So angle between them is 0. Then flux passing from this surface, E ds cos 0. E root 2 alpha a square, ds a square cos 0 1. So is equal to root 2 alpha a raised to 5 by 2. Clear? Now what is total flux passing from Q? Phi is equal to phi 1 plus phi 2. It is value of phi 1, it is value of phi 2. Alpha a raised to 5 by 2, alpha a raised to 5 by 2 common. Alpha a raised to 5 by 2 common. Minus 1 and here it is root 2. It is root 2 minus 1. Now it is calculation. What is value of alpha? 800. A 0.1. Root 2 means 1.41 minus 1. 800. 0.1 raised to 5 by 2. See, you can use calculator, okay? 0.15 times and then it's square root. Your answer will be 0.003162. 1.41 minus 1 it is 0.41. If you calculate this, you will get answer 1.037 Newton meter square per coulomb. It is flux passing from Q. It is flux passing from Q. Now your second question is, you have to find what is charge enclosed by Q. Use this equation. Phi is equal to sigma q upon epsilon 0. So sigma q is equal to phi epsilon 0. Phi 1.037 into what is value of epsilon 0? 8.85 into 10 raised to minus 12 is equal to 9.17 into 10 raised to minus 12 coulomb. So it is one question based on Gauss law. See, in this case, as electric field is non-uniform, total flux is not zero. If electric field is uniform, from such symmetrical object, electric flux will be zero. For uniform electric field, for such symmetrical object, for example as for cube, electric flux passing from it will be zero. Pause video, write down in your notebook. Knowledge students, send notes on my WhatsApp number, and for other school students, send notes to your respective subject teachers. Good morning students. Lecture 2. One more example based on Gauss law. Example 1.12. See, one uniform electric field is given, but uniform electric field only for magnitude. See, for x greater than 0, that is on positive x-axis, electric field is 200 I caret Newton per coulomb. Means electric field is in positive x direction. For x less than 0, electric field is minus 200 I caret Newton per coulomb. Means in positive x direction and negative x direction, Magnitude is same, but direction is opposite. One cylinder is given having length 20 centimeter and radius 5 centimeter. Its center is at origin and its axis is on x-axis, coinciding with x-axis. One face is at plus 10 centimeter and another face is at minus 10 centimeter. You have to find 4 questions. First, find flux for flat surface, find flux for side, find total flux, and what is charge enclosed by this cylinder. Okay, first of all, you have to understand figure. What is figure? See here, it is one cylinder having length L and its radius R. Its radius R. Okay, its center is at origin. It is positive x direction, it is negative x direction. For positive x direction, x greater than 0, E is equal to 200 I caret. I caret means electric field is in positive x direction. Clear? Okay. For x less than 0, means on negative x axis, electric field is minus 200 I caret, means magnitude is same but direction is opposite. Clear? We have to find 4 questions. See, first question. Question A. Find flux for flat faces. For this right flat face, this one, and for this face, and for this face. Okay, so first of all, for right face means this face. What is equation of flux? Phi 1 is equal to E ds cos theta. How to find theta? That is angle between E and ds. See, for this face, area vector perpendicular outside ds. See, this face is on x greater than 0, means in this direction. In this direction, E and ds, they are parallel to each other, means angle between them is 0. Okay, ds means area having radius r, ds is equal to pi r square, pi 3.14, r 5 centimeter, you have to convert in meter, 0.05 whole square, so your answer is 0.00785 meter square. Okay, E 200, only magnitude, ds cos 0 it is 1, so your answer is 1.57 Newton per Coulomb meter square. Clear? Okay, it is flux passing from this right face. What is flux passing from this left face? See, again same equation, phi 2 is equal to E ds cos theta. Electric field on x less than 0 is in this direction. Area vector for this flat surface perpendicular outside, again E and ds, they are in same direction, angle between them is 0. E, magnitude of electric field 200, ds, similar area, cos 0, it is 1. So you will get the same magnitude, 1.57 Newton per Coulomb meter square. So it is flux passing from flat surfaces. Now third question is flux passing from side. Side means this curved surface. This curved surface. See, if you take element at any point on this side, for example, let we take one element here, we take one element here, then we know that area vector is always perpendicular outside. It is ds. From figure it is clear, E and ds, they are perpendicular to each other. If you take element at this point, then it is perpendicular outside area vector. Again, E and ds, they are perpendicular to each other. So for any point on side, E is perpendicular to ds. So phi is equal to E ds cos 90. Flux is equal to 0. Flux is equal to 0. So it is question B. Question C, you have to find net flux. Net flux means total flux. Total flux passing is equal to phi 1 plus phi 2 plus phi 3. 1.57 plus 1.57 plus 0 is equal to 3.14 Newton meter square per Coulomb. And last question is, what is charge enclosed by this cylinder? Phi is equal to sigma q upon epsilon 0. So sigma q is equal to phi epsilon 0. Phi epsilon 0, calculate, it is 2.78 into 10 raised to minus 11 Coulomb. So it is again one question based on application of Gauss. Pause video, write down in your notebook, send notes on my WhatsApp number. For other school students, send notes to your respective subject teachers.